What's up YouTube? Chris Bandy here. I'm going to show you how to solve the 4x4x4 Rubik's Cube. If you have a question, read the description before commenting. Okay, let's get right into it. There are two main steps to solving the 4x4. The first step is converting it into a 3x3, and the second step is solving it almost exactly the same way you solve a 3x3. After converting it, the 4x4 will look something like this. Each edge is really made up of two edge pieces, and each center is really made up of four center pieces. We'll start by learning how to solve these centers. Start by finding two white center pieces, here and here. Now, we need to put these two center pieces next to each other on the same face. So if I want a centerpiece to be next to this one, I need to put one here. Since the destination is in the top right of this center, we rotate this face until this white centerpiece is in the top right of its own center. Then we just push it up to make a white bar. Now, use the other two white centerpieces to make another bar in the same way. The only difference is that you need to make sure every move that you do does not break the bar you've already made. If I want to push this one up here to make my second bar, all I need to do is check. Will doing this move break my first bar? Let's see. Yes, it will. So all I need to do is rotate the face that this bar is on, clockwise or counterclockwise. Now we return to our two white centerpieces that need to be joined, and we push the bottom one up. Did our first bar get broken? Nope, it got moved, but not broken, so that's fine. Now we just make sure that both bars are vertical, and also make sure that they are in adjacent slices. This one's in the right, and this one's in the left. Then we just push them together to solve our white center. Now we need to build the yellow center opposite the white center. So let's put the white center on the bottom. If you don't have any yellow centerpieces on the top, just pull one from one of the sides. Here's one. We'll move it up to the top using the spin algorithm. The side comes up, spin the top inwards with that same hand, and the side goes down. It may take a few tries to get this yellow piece on top. So let's do it again. The side comes up, spin the top inwards with that same hand, and the side goes down. There we go. Now we need to put another yellow centerpiece on the top face next to this one. So pick another one from around the sides of the cube. Here's one. The top piece is on the right half of its center, as you can see. So we need to rotate this face until this centerpiece is also on the right half of its own center. There we go. Then we do the same spin algorithm, this time using the right side, because the pieces are on the right side. Side comes up, spin top inwards, side goes down. It may take a few tries, but eventually it will give you a yellow bar on top. Side comes up, spin top inwards, side goes down. There we go. Here are the final two yellow centerpieces. Maneuver them until they are on adjacent faces. Then build these two yellow centerpieces into a bar using the methods we've already covered. We need this one to go just above this one. Since the destination is in the top right of its center, we need to rotate this face until this yellow centerpiece is in the top right of its own center. Then we just push it over to make our second yellow bar. We make sure that both yellow bars are vertical and in the same slice. To put them together, do the spin algorithm twice. Side up, spin inward, side down. Side up, spin inward, side down. There's our yellow center. After solving the yellow center, you will need to solve the red center. Turn the cube sideways so that white is on the right. Let's go through all of the red center cases. This is the 2-bar case. Make sure both bars are vertical and in adjacent slices. Then just join them together. This is the dot case. It doesn't matter whether the dot is on the front face or the top face. Make sure that both the dot and the V shape are pointing down and right. So here, the V is pointing up and right. So we need to rotate its face until it's pointing down and right. Similarly, the dot is pointing up and left. So we need to rotate its face until it is also pointing down and right. Then do the spin algorithm. Side up, spin inwards, side down. This will either solve your center or get you to the 2-bar case, which we've already covered. This is the diagonals case. Make sure both patterns point in opposite directions. Since this one points right, we need this one to point left. Then do the spin algorithm from either side. Now we have the dot case, which we've already covered. This is the 1-bar case. It doesn't matter whether the bar is on the front face or the top face. Make sure the bar is vertical, then do the spin algorithm from either side, and you will end up with a case we've already covered. The polar case is when your red centerpieces are all on 2 opposite centers. Just pick one of these centers, hold it in the front, and do the spin algorithm repeatedly on each side until you've moved all of these red centerpieces up to the top. So I'm going to spin on the right. Okay, we'll do that again. Okay, that piece is moved to the top, and then we'll do on the left. There we go. The pieces are moved successfully to the top, and now we have a case we've already covered. The scatter case is when your red centerpieces are scattered across 3 or 4 faces. Use the same methods as you did for the previous centers to group individual pieces into bars and then put the bars together. For example, I want to put this red centerpiece next to this one, so it needs to go here. Destination is bottom left, so I need to put this centerpiece into the bottom left of its own center by rotating the face. There we go. Then I push it up to join these together. When you make a bar, turn it vertical so it won't get messed up. Keep joining pieces this way until you encounter a case that we've already covered. After solving the red center, the blue center needs to be solved directly below it. This time, however, you need to make sure you don't break the red center while you're solving the blue center. If you just move one of the sides up to make a blue bar, you will break your red center. So you have to use the spin algorithm in its entirety. So if we want to put these two together, I do side up, spin inward, side down. So the problem here is that this is supposed to be the blue center, but now I've got a bar down here. That's okay. Just use the spin algorithm until the bar gets moved up. Okay, then we're going to move these two upwards using the spin algorithm. There we go. You can't just join these bars together, because doing so will break your red center. You need to line the blue bars up in the same slice, and then do the spin algorithm. There we go. You may end up with the blue center built, but in the wrong spot. For example, the blue center is supposed to be here, just below the red center. But what if it's all the way down here? That's okay. Do the spin algorithm twice on both sides to move it upwards. Side up, spin inwards, side down. Side up, spin inwards, side down. Now the left side. There we go. We've moved it up. It needs to go here, so we need to move it up one more time. There we go. Our last two centers are the green and orange centers. Keeping white on the right, orange should be above green. This is the 2-bar case. Make sure both bars are vertical and that the colors match vertically. So here, green is always on the right side and orange is always on the left side. Then do the spin algorithm twice on the orange side. There we go. This is the dot case. Make sure that this orange dot is on the bottom right and that the orange V is also pointing towards the bottom right. Then do the spin algorithm on the right side. This is the 1-bar case. It doesn't matter whether the bars are on the top face or the front face. Make sure the bars are vertical. Do the spin algorithm on whatever side you see a vertical orange bar. There we go. This is just the dot case, which we've already covered. This is the anti-dot case. The problem here is that this center is supposed to be green, even though right now it's mostly orange. Do the spin algorithm on whatever side you see a vertical orange bar, but first move the orange dot over to that same side. For this one, our vertical orange bar is on the right side, so we move the dot over to the right. Then we do our spin algorithm. There we go. This is just the 2-bar case, which we've already covered. This is the diagonals case. Do the spin algorithm on either side, and you'll get a case that we've already covered. If your orange and green centers need to be switched, do the spin algorithm twice on both sides. There we go. Our centers are solved. After solving your centers, make sure they are correct. If yellow is on top, white should be on the bottom, and the order around the sides should be, going rightwards, red, green, orange, and blue. If your centers are not exactly like this, you need to go back and switch some of them using the center switching techniques that we've already covered. Now we need to build the 12 edges. So, find 2 edge pieces that are exactly the same. Orange yellow, orange yellow. By turning the outer layers only, we need to maneuver these 2 edges so that they are on the same face, but on adjacent slices. So if this orange-yellow edge is here on the upper slice, that means we need to move our other orange-yellow edge onto the lower slice. Just like this. This is wrong. The 2 edge pieces should not be in the same slice. Just do R prime, U, F prime to fix this. Now they are on adjacent slices on the same face. When you've got your 2 edge pieces in adjacent slices on the same face, hold the cube so that one edge piece is in the upper slice and the other is in the lower slice. We'll call this face the front face for now. For this to work, this edge here, the one that's to the outside and above the lower slice edge piece, this edge must be broken, which means the 2 edge pieces it's made of must be different, like this. If the edge here is already built, like this, just rotate the top layer until the edge that is in this spot is broken, like this. If all of the edges in the top layer are already built, like this, look on the back face. So since this is the front face, this will be the back face. If you find a broken edge on the back, like this, just rotate it up to the top, and then rotate it around the top to that spot that is just over the lower slice edge piece. Then you're good to go. If you can't find a broken edge on the top or on the back, you should be able to find one in the bottom layer, like this. Rotate that broken edge around until it is in the back, like this. Rotate the back face twice so that the broken edge goes to the top, and then rotate that broken edge around the top until it is above and outside of this lower slice edge piece. And you're good to go. When you are good to go, connect your 2 edge pieces together by pushing the top 2 layers over. There's our new edge. Do the spin algorithm on the side of the new edge, using only the outer layers. Then turn the top 2 layers back to fix all the centers. If you are connecting to the left, it's going to look like this. make sure the edge that is to the outside and is over the lower slice edge piece, make sure this edge is broken, like this. Connect your two edge pieces together by pushing the top two layers over. There's our new edge. Do the spin algorithm on the side of the new edge, using only the outer layers. Then turn the top two layers back to fix all the centers. Keep doing this until you either build all your edges or you have exactly two broken edges left. Okay, so let's do orange, green, orange, green. As you can see, they're on the same face, but they're in the same slice, which is wrong. We know that doing R prime, U, F prime will put them correctly in adjacent slices on the same face. We check, this is a lower one. This edge needs to be broken, which it is, so we turn the top two layers over. Spin move, top two layers back. There's our new edge. Let's do red, blue, red, blue. They're on the same face, but they're not quite correct. If we move one of these out, and then rotate that face to put this one in a different spot on the face, then we can put this one back in and see if it's correct. Yes, it is. This edge needs to be broken, which it is, so we're going to do the same thing. Okay, let's do white and blue. Since they're on the same face, but they're incorrect, we're going to move this one away, and then we realize that we're actually only one move away from them being correct. If we just move this one down, now they're in adjacent slices on the same face. This edge needs to be broken. Now it is, so we push these together. Spin move, fix our centers. Okay, so we've got two broken edges left. Go ahead and position them as if you were about to build one of them. So let's say we want to build the green-white edge. So we're just going to move one of them away from that face. Now we notice that we're only one move away from them being correct. If we just move this one up, they're back on the same face, and they are in adjacent slices. We need this edge to be broken. The problem is, there are no broken edges to use. Instead, hold the cube so that your last two broken edges are in the front and back of the top face. Then do this algorithm. Wide left prime, U2. Wide left prime, U2. F2, wide left prime, F2. Wide R, U2, wide R prime, U2. Wide L2. Now the cube is converted into a 3x3, so you can go ahead and start solving it like one. If you get to the face step and are trying to solve your yellow cross, but it is missing exactly one of its edges, like this, you've encountered the OLL parity. It's the same thing if you get this stump where only one yellow edge is oriented. If either of these happens to you, do the following algorithm anywhere on the cube. Wide right 2, B2. U2, wide L, U2. Wide R prime, U2, wide R, U2. F2, wide R, F2. Wide L prime. B2, wide R2. This algorithm is not supposed to solve your cube or complete the yellow cross. All it does is flip one edge, thus getting rid of the OLL parity. So let's keep solving. If you get to the dodge step and are trying to position your corners, but exactly two yellow corners are in the correct places, which means the other two yellow corners need to be swapped, like this, you've encountered the PLL parity. It's the same idea if none of the yellow corners are in the correct places, and you do the dodge, but after you're done, still none of the yellow corners are in the correct places. If either of these happens to you, do the following algorithm anywhere on the cube. Small r2, which means rotate just this inner right slice 180 degrees. U2, small r2, wide U2, small r2, wide U2. Just like last time, This algorithm is not supposed to solve anything. All it does is swap two pieces on the cube, thus getting rid of the PLL parity. Once both parities are resolved, you will be able to finish solving the cube just like a 3x3. Alright, I hope this tutorial has helped you. If it has helped you, show it to your friends who also want to solve the 4x4. If you need help, follow the description and then feel free to post a comment. Thanks for watching.
And my name is Quinn, and I like to solve a Rubik cube.